Hello and welcome to this lesson on plotting graphs using tables of values. By the time you finish this video, you will be able to first, identify the x-axis, y-axis, origin, and coordinates on a graph. Second, understand how to complete a table of values for linear and quadratic equations. Third, apply tables of values to accurately plot and sketch graphs. Let's get started. Now, let's begin by looking carefully at the coordinate grid. This is the foundation of plotting any graph, so it is very important that we understand every part of it clearly. At the center of the grid, we have a point marked 0, 0. This point is called the origin. The origin is where the two axes meet, and it is the starting point for all coordinates on the graph. Now, look at the horizontal line going across the grid. This is called the x-axis. The x-axis shows the values of x. As we move to the right, the values of x increase. As we move to the left, the values of x decrease. Now look at the vertical line going up and down. This is called the y-axis. The y-axis shows the values of y. As we move upwards, the values of y increase. As we move downwards, the values of y decrease. Now let's talk about coordinate pairs. Every point on the graph is written as a pair of numbers in the form xy. The first number tells us how far to move along the x-axis. The second number tells us how far to move along the y-axis. For example, the origin is written as 0, 0 because we do not move in either direction. If we had a point like 2, 3, we would move 2 units to the right and then 3 units up. It is very important to remember the order. Always move along the x-axis first, then move along the y-axis. This coordinate system allows us to plot points accurately, and once we plot several points, we can begin to form a graph. So before we move on, make sure you are comfortable with these ideas. The x-axis, the y-axis, the origin, and coordinate pairs. These are the building blocks for plotting graphs using tables of values. Now, let's look at an example of how we use a table of values to plot a graph. The equation we are working with is y equals x squared. This is a quadratic equation, and it will produce a curved graph. Now, instead of guessing the shape, we are going to calculate specific values. Look at the table. We choose values for x. Here we have -2, -1, 0, 1, and 2. Now for each value of x, we substitute it into the equation y equals x squared. Let's go through this slowly. When x is -2, y equals -2 squared. This gives 4. When x is -1, y equals -1 squared. This gives 1. When x is 0, y equals 0 squared. This gives 0. When x is 1, y equals 1 squared. This gives 1. When x is 2, y equals 2 squared. This gives 4. So now we have a complete table of values. Next, we use these values to plot points on the graph. We plot -2, 4, then -1, 1, then 0, 0, then 1, 1, then 2, 4. Now look at the pattern. The points form a smooth curve. They are symmetrical about the y-axis. As we join the points carefully, we get a U-shaped curve. This is the graph of y equals x squared. So the key idea here is this. We use a table of values to calculate points step by step, then plot those points, and finally join them to form the graph. This method helps us draw graphs accurately, especially when dealing with curves like quadratic graphs. Now, let's build on what we've just done and look a little deeper at this graph. We already have the equation y equals x squared, and we have completed the table of values. We also plotted the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now, look carefully at the graph again. There is something very important about its shape. Notice how the left side of the graph is a mirror image of the right side. For example, -2, 4, and 2, 4 are at the same height. Also, -1, 1, and 1 line up perfectly across the graph. This tells us that the graph is symmetrical. Now, look at the center line of this symmetry. It passes through the point 0, 0 and goes straight up and down. This is called the line of symmetry. For this graph, the line of symmetry is x equals 0. Now let's connect this to the general form of a quadratic. A quadratic equation can be written as y equals ax squared plus bx plus c. For this example, a equals 1, b equals 0, and c equals 0. Now there is a formula that helps us find the line of symmetry. X equals -b divided by 2a. Substitute the values into the formula. b is 0 and a is 1. So we get x equals negative 0 divided by 2 multiplied by 1. This gives x equals 0. So this confirms what we saw from the graph. The line of symmetry is x equals 0. Now take a moment to connect everything together. The table of values helped us find accurate points. The points helped us draw the graph. And the graph shows us important features like symmetry. This is why tables of values are so useful. They do not just help us plot points, they also help us understand the structure and behavior of the graph. Now, let's dive into some exam-style practice question. You can pause the video and try yourself. Question 1. The graph is defined as y equals 6 minus 2x squared. Part A. Complete the table. Now take your time with this question. We are given an equation and we are asked to complete a table of values. This means we must substitute each value of x into the equation and carefully calculate the corresponding value of y. Let's go step by step. The equation is y equals 6 minus 2x squared. Now look at the table. The x values are negative 2, negative 1, 0, 1, and 2. We will calculate y for each of these values. Start with x equals 0. Substitute 0 into the equation, y equals 6 minus 2 multiplied by 0 squared. 0 squared is 0, so this becomes 6 minus 0, so y equals 6. This earns 1 mark. Now take x equals 1. Substitute 1 into the equation. Y equals 6 minus 2 multiplied by 1 squared. 1 squared is 1, so this becomes 6 minus 2. So y equals 4. This earns 1 mark. Now take x equals 2. Substitute 2 into the equation. Y equals 6 minus 2 multiplied by 2 squared. 2 squared is 4. So this becomes 6 minus 8, so y equals negative 2. This earns 1 mark. Now because this is a quadratic expression, the values will be symmetrical. So the value for x equals negative 1 will be the same as for x equals 1. So y equals 4. And the value for x equals negative 2 will be the same as for x equals 2. So y equals negative 2. Now we have completed the table. So the final answer is the completed table of values. Question 1, Part B. Plot using the pairs from the table. Now, this part builds directly from Part A. We have already completed the table of values, so now we will use those values to plot the graph. Take your time here because accuracy is very important. First, list the coordinate pairs clearly. We have negative 2, negative 2, negative 1, 4, 6, 1, 4, and 2, negative 2. Now we begin plotting. Start with the point negative 2, negative 2. Move 2 units to the left on the x-axis, then move 2 units down on the y-axis. Plot the point carefully. This earns 1 mark. Next, plot negative 1, 4. Move 1 unit to the left, then 4 units up. Plot the point clearly. This earns 1 mark. Now plot 0, 6. Stay at 0 on the x-axis, then move 6 units up. This is an important point because it is the highest point of the graph. Plot it carefully. This earns 1 mark. Next, plot 1, 4. Move 1 unit to the right, then 4 units up. You should notice this lines up horizontally with the point negative 1, 4. Plot it clearly. This earns 1 mark. Finally, plot 2, negative 2. Move 2 units to the right, then 2 units down. This lines up with the point negative 2 on the opposite side. Plot it carefully. This earns 1 mark. Now look at all the points together. They form a curved shape. Join the points with a smooth curve, not straight lines. The curve should go up to the highest point at 0, 6, then come down symmetrically on both sides. So this graph is a downward opening parabola. Take a moment to check your graph. Make sure all points are plotted correctly and the curve is smooth and symmetrical. Question 1, Part C. Write down the equation of the line of symmetry. Now this part is about identifying the center of the graph. We already plotted the graph in Part B, so we can use that information here. Look carefully at the graph. Notice how the left side and the right side are mirror images of each other. For example, negative 1, 4 and 1, 4 are at the same height. Also, negative 2, and 2, negative 2 line up perfectly across the graph. This tells us that the graph is symmetrical. Now look at the middle of this symmetry. The highest point of the graph is at 0, 6. This point lies exactly on the center line, so the line of symmetry passes through x equals 0. Now let's confirm this using the formula. The formula for the line of symmetry is x equals negative b divided by 2a. From the equation y equals 6 minus 2x squared, we can identify the values. A is -2, B is 0, and C is 6. Now substitute into the formula x equals -0 divided by 2 multiplied by -2. This simplifies to 0 divided by -4. So x equals 0. This earns 1 mark. So the final answer is x equals 0. This earns 1 mark. Now take a moment to connect this to the graph. The line of symmetry is a vertical line that passes through the center of the parabola. It divides the graph into 2 equal halves.